Good day. I will discuss additional problem solving involving plane in space, specifically equation of a plane. So we have here, write an equation of the plane through the points A, B, and C. So to solve this problem, let us draw a plane containing now these 3 points. So we have here a plane, then we have 3 points on this plane, which are A, B, C, and their corresponding coordinates. Suppose this is point A, then this is point B, and then this is point C. So we have here 3 points on a plane. Wherein we can define also two vectors from these 3 points. If we are to take the initial point is as point A, then AC will be our vector U, and we have AB as our vector V. In the equation of a plane, we need to find a normal, vector, and an initial point. So in this case, let us take A as our initial point, whose coordinates are already given. So we have the coordinates as 1, 0, -1. Then the formula to be used in finding the equation of the plane is the normal point form, which is A multiplied by x minus x sub 0 plus B multiplied by y minus y sub 0 plus C multiplied by z minus z sub 0 equals 0. So with this, let's now find normal vector. If you recall last time, we have the same two vectors u and v, and we have the cross product of these two vectors, which is perpendicular to both vectors u and v. So if we denote this as our u cross v vector, wherein it is perpendicular to both these two vectors u and v, so we can also say now that this u cross v is actually the normal to the given plane, because we have defined normal vector last time as a vector perpendicular to the plane. So with that, let's now define the components of your normal vector, that is u cross v. So defining now u, vector u, which is vector AC. So we have initial point is A, terminal point is C. So we have 4 minus 1 is, we have it as 3. 5 minus 0 is 5. Then -1 minus -1 is 0. So that is your vector u. Then vector v can be found by having vector AB. And let us get the components of your vector AB. So we have it as the initial point is A, terminal point is B. So we have 3 minus 1 is 2, 3 minus 0 is 3, 2 minus -1 is 3. So with that, we now get the cross product of these two vectors, which will be our normal vector for the plane. So we have now a matrix form, that is for the first row ijk, and then we have the second row is the component of your vector u350, and then we have the third row is the component of your vector v233. So this forms now a 3 by 3 matrix, and getting its determinant, we will use the basket method. So we have I32, J53. So with that, let's now get the determinant of this matrix. And this will now be our cross product, which in turn will be our normal vector. So we now perform diagonal multiplication. So we have 15i, then this is 0j, then plus 9k, minus we have 10k, then we have 0i, then you have plus 9j. So simplifying, we have now 15i minus 9i, or rather this is 15, 9k, then 10k, 0i, then this is 9j. So therefore, this is now 15i minus 9j. 9k minus 10k will be negative k. So therefore, the components of your normal vector in bracket form, we have it as 15, negative 9, negative 1. So we have already found the normal vector n. So this will be our components A, B, C. So with that, we can now substitute those values that we have obtained. So we have 15 then multiplied by x minus x sub 0. We have the initial point is at point A, so that is 1. Then minus 9, that is your B. And then you have y minus 0. Then C is negative 1. Then you have then z minus minus 1, that will be z plus 1. So simplifying it, we have 15x minus 9y minus z, then you have negative 15x, then you have 0, then negative 1, that will be negative 16 equals 0. So this is now the equation of the plane when you have the condition given that we have 3 points on the plane. Let's have another example. It says here, find the equation for the plane through the point 1, negative 1, 3, parallel to the plane 3x plus y plus z equals 7. So if we're going to graph the two planes here, they are said to be parallel. So we have here our plane 1. Let us have this as the unknown plane. And it has a point whose coordinates we have it as 1, negative 1, 3. Then we have another plane, so this is plane 1, another plane which is plane 2 being parallel to plane 1. And the equation of this plane 2 is we have 3x plus y plus z equals 7. So with that, what we need for our plane to define the equation of plane 1 is we have to find the normal vector and a point, but the point P is already given, whose coordinates are 1, negative 1, 3. So let's now have the normal vector of plane 1 determined. So it should be perpendicular to, the vector should be perpendicular to the plane 1. For plane 2, we also have it as a normal vector perpendicular to plane 2. So this is your n2, while this is your n1. Now, to define the components of n2, it will only be the coefficients of x, y, z of the equation of your plane 2. So we have it as 3, 1, 1. And since we can see that these two normal vectors are parallel, we can say that normal vector 1 will also have the same components as your normal vector in plane 2. So we have also it as 3, 1, 1. So from here, We have already obtained the components of your normal vector 1, and we can now define its equation. Remember that this is the unknown plane. So using now the equation point normal form of equation of plane, we have a multiplied by x minus x sub 0 plus we have b times y minus y sub 0 plus c times quantity z minus z sub 0 equals 0. So substituting now this normal vector and a point. So we have here now a is 3 multiplied by x minus 1. That is from the coordinate, x coordinate of your point P. Then you have plus b is 1 multiplied by y minus negative 3. That will be y plus 1. Then plus c is also 1 multiplied by z minus 3 equals 0. So with that, we now have 3x plus y plus z. Then we have negative 3 plus 1 is negative 2 minus 3 is negative 5. So this is now the equation of the plane.